Okay, so we're going to do a quick quadratic formula review. And the way I prefer to do it, you don't actually ever write down the quadratic formula. You need it, of course, to be able to utilize it. And so that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our formula. However, really in the nuts and bolts of it, you don't have to keep writing it down over and over, which makes quadratic formula pretty laborious. What you really need are your a, b, and c values. In any quadratic equation, standard quadratic equation is y equals ax squared plus bx plus c. These are the values that we're concerned with. If you can find your a, b, and c values, then you're good to go with quadratic formula. So, and the one that you're really concerned with is what's underneath the radical sign, that b squared minus 4ac. So we first are going to try 2x squared plus 3x minus 20 equals 0. So our a, b, and c values are 2, 3, and negative 20. That discriminant, the part underneath the radical, is b squared minus 4ac. This part is easy, and yet it is the most problematic part of quadratic formula, mostly because of this negative 4ac section right over here. So if we break it down, it's not so hard. So our b squared value would be 9 minus 4 and 2 times negative 20. I put that into one calculation. You can usually do this in your head. Would be negative 40. So now we get 9 plus 160, which equals 169. This is the part that's going to go under the radical. Now it just works out this time that that radical part is a perfect square. 169 is a perfect square. Square root of 169 is 13. So this can simplify. All of this mess simplifies down to 13. Now we just have to add in the rest of our formula. So in the front of our plus minus is going to be the opposite of b, which would be negative 3, all over 2 times our a value, which is 2. So we have over 4. Now, in the case that you have only whole numbers left like this, you have no radicals left, you're going to solve this twice. One is negative 3 plus 13 over 4. The other one would be negative 3 minus 13 over 4. That should be a 4. Okay? So let's go on to the next page and solve that out. So you have negative 3 plus 13 over 4 and negative 3 minus 13 over 4. So 1 would be 10 over 4. That reduces to 5 halves. That's one of your solutions. Remember, in quadratic equations, you always have 2 solutions. Actually, not always. Sometimes you have none. Sometimes you have 1. Most of the time, you have 2. And then here you would have negative 16 over 4, which gives you negative 4. So there's our 2 solutions. No radicals left, nothing awful to look at. Let's go ahead and do one that doesn't clean up so nicely. So the next one would be 8n squared minus 7n minus 8 equals 0. So start the same process. A, B, and C are 8, negative 7, and negative 8. Our b squared minus 4ac value would be, our b value is negative 7. Negative 7 squared is 49. 9. Wow. Clean that up for you. 49 minus 4 times 8 times negative 8, which would be negative 64. That gives you 49 plus 256, which is a total of 305. This is the amount that is our discriminant. That's our value of our discriminant, which goes underneath the radical sign. So you have square root of 305. Now, I'm going to check to see if anything factors out of that, but I don't believe that it does. I know 5 will go into both. 5 goes into 360 times, plus 1 more because of that 5. So you have 61 times 5. Neither one of these are factorable. They're both perfect squares. So we can't simplify square root of 305 any farther than that. So that's going to be our discriminant portion right there. Now we just have to add in the rest. The opposite of our b value would be 7. Double our a value would be 16. There's nothing in these coefficients that simplifies. So this is going to be our final answer. I hope that helped. And practice, practice, practice. Thanks.